Good day, learners. Today we are going to discuss equation of parabola in standard form whose vertex is located at the point of origin. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be updated for my upcoming videos. In this video lesson, we are going to discuss how to find and what are the equations of the parabola in standard form whose vertex at the point of the origin. And in this video lesson, you will know how to sketch parabola whose vertex at the point of origin. As we are going to define parabola, parabola is a set of all points in a plane equidistant from a fixed point and a fixed line in that plane. Suppose that this is now our parabola. Let us now discuss what are the most important parts of the parabola. The first is what we call the vertex, a point where the parabola crosses its axis. Next is the focus. The focus is the fixed point, and we have now the directrix. When we say directrix, that is the fixed line. Let us discuss the definition of the parabola. It has been said that it is a set of all points in a plane equidistant from a fixed point and a fixed line. So if we are going to get one point on the parabola, suppose this is our point P, and we are going to create a line that connects point P and the focus, and a line that connects point P and perpendicular to the directrix. So as what you can see, their distances are equal. So if we're going to get another point on the parabola, so suppose that if this is our point P, so as we are going to draw a line that connects point P and the focus, and a perpendicular line that connects point P going to the directrix, then their distances are equal. And suppose if we have another one, this is now point on parabola. So as what you can see, their distances are equal also. Another one, if this is our point P on the parabola, as we are going to draw a line that connects point P and the focus, and a perpendicular line that connects point P going to the directrix, then their distances are equal. And we have now the latus rectum. So this is now our latus rectum. As we are going to define latus rectum, this is the chord that drawn through the focus and perpendicular to the axis of the parabola. And we have now the axis of symmetry. So when we say axis of symmetry, this is the line through the focus and perpendicular to the directrix. This is the line that divides the parabola into two equal parts, and this line will pass through the focus and the vertex. And so if you're going to look at now the relationship between the axis of symmetry and the directrix, they are perpendicular. Let us discuss equation of the parabola in standard form whose vertex is located at the point of origin. The first equation is y squared is equal to 4px. So if the equation of the parabola is in this form, then we can say that the vertex of the parabola is located at the point of origin. Then try to look at now this expression at the right of the equation. So since this is now a positive, then this gives us an idea that the opening of the parabola opens to the right, because the directrix of the parabola is parallel to y. This gives us an idea that when y is being squared, then the directrix is parallel to y. This constant p here tells us the distance between the vertex and the directrix, and the distance between the vertex and the focus. And also this tells us the length of the latus rectum, because if we're going to get now 4 times of the value of the p, that gives us the length of the latus rectum. Let us find the coordinates and the equations of the parts of the parabola y squared is equal to 4px. For the vertex is coordinate 0 and 0, which is the point of the origin. And for the focus, this is our focus, the coordinate is P and 0. For the directrix, so we're going to have an equation that represents now this line, which is the x is equal to negative p. For the axis of symmetry, which is now the x-axis, so the equation is y is equal to 0, and the length of the latus rectum is 4 times the value of the p. The focus is coordinate p and 0. So just replace now our ordinate 0 by positive negative 2p to identify now the coordinates of the end of the latus rectum. So the coordinate of the end of the latus rectum is coordinate p and positive negative 2p. Next equation is y squared is equal to negative 4px. Then we can say that if it is in this form, the vertex of the parabola located at the point of origin, and since now y is being squared, then this tells us that the directrix is parallel to y-axis. And also, if we're going to look at now this expression at the right of the equation, it is negative, then it tells us that the parabola opens to the left. And also, the value of the p is the distance from the vertex going to the directrix, from the vertex going to the focus, and 4 times of it is the length of the latus rectum. And the equation and the coordinates of the parabola having an equation of phi squared is equal to negative 4px. So the vertex is located at the point of origin, which is coordinate 0 and 0. This is our focus, which has a coordinate of negative p and 0. For the directrix, this is our directrix. So the equation that represents our directrix is x is equal to p. For the axis of symmetry, so our axis of symmetry is the x-axis. So the equation of the x-axis is y is equal to 0. Then our length of latus rectum is 4 times the p, or 4p. And the coordinates of the end of the latus rectum. So we have now negative p plus minus 2p. So try to look at now the focus. The focus is negative p and 0. So in order for us to identify now the coordinates of the end of the latus rectum, we're going to use this one. We are going to use coordinate negative p and 0. Instead of 0, replace it by plus minus 2p. So we have now the coordinates of our end of our latus rectum is coordinate negative p and plus minus 2p. The third equation of the parabola in standard form when the vertex is located at the point of origin is x squared is equal to 4py. As what you can see in this equation, the degree of term of the variable x is 2, then we can say that the directrix is parallel to x-axis. Since now this expression at the right of the equation is positive, then it gives us an idea that the opening of the parabola is upward. And take note that the distance between the vertex and the directrix is p units, and also the distance from the vertex going to the focus upward is p units. And our latus rectum is 4 times the value of the p. And the axis of symmetry is the y-axis. Let us identify the equation and the coordinates of the parts of the parabola x squared is equal to 4py. So the vertex is located at the point of origin having a coordinate of 0 and 0. Then the focus, this is our focus, having a coordinate of 0 and p. For the directrix, the equation of the directrix is y is equal to negative p. For the axis of symmetry, since our axis of symmetry is the y-axis, then the equation of the y-axis is x is equal to 0, and the length of the latus rectum is 4p. For the coordinates of the end of the latus rectum, so try to look at the focus. The focus has a coordinate of 0 and p. So to identify the coordinates of the end of the latus rectum, the 0 here must be replaced by plus minus 2p, so that now we can have our coordinates for the end of the coordinates of the endpoints of the latus rectum, which is coordinate positive, negative 2p and p. And the fourth equation of the parabola when the vertex is located at the point of origin is x squared is equal to negative 4py. So as what you can see also that the degree of turn for the variable x is 2, then the directrix is parallel to x-axis. Since now this expression is negative, the negative 4py, then this gives us an idea that the parabola opens downward. Then the distance between the vertex and the directrix, and also the distance of the vertex and the focus downward is p units, and our latus rectum is 4 times the value of the p. The equation and coordinates of the parts of the parabola x squared is equal to negative 4py. Our vertex is located at the point of origin having a coordinate of 0 and 0. Our focus here, the coordinate is 0 and negative p. For the directrix, this is our directrix, so the equation represents now y is equal to p for the directrix. And for the axis of symmetry, since the axis of symmetry is the y-axis, then the equation represents the y-axis is equal to x is equal to 0. For the length of the latus rectum is 4 times the value of the p. For the coordinates of the end of the latus rectum, to identify the coordinates of the latus rectum, just look at the focus. Our focus here is 0 and negative p. So the abscissa is 0. So instead of writing the 0, replace it by positive negative 2p. Then we can say that the coordinates of the endpoints of the latus rectum is coordinate positive negative 2p and negative p. Thus, here is the table for the standard equation of parabola where vertex is located at the point of origin. Example number 1. Sketch and discuss y squared is equal to 4x. The equation y squared is equal to 4x is a parabola with vertex at the origin. So all we have to do, we are going to set for our 4p. So in order for us to find the value of the p, we are going to divide both sides by 4s. Then we can say the value for p is equal to 1. So as what you can see, the given equation y squared is equal to 4x is in the form of y squared is equal to 4px in standard form. The vertex is at the origin coordinate 0 and 0. Then the equation of the directrix is x is equal to negative p. The focus is coordinate p and 0. The equation for the axis of symmetry is y is equal to 0. And the length of the latus rectum is 4 times the value of the p. And for the coordinate of endpoints of latus rectum is coordinate p and positive negative 2p. So by substituting now the value of the p, we can now identify now the parts of the parabola. Vertex is at the origin coordinate 0 and 0. Then the directrix, substituting now the value of the p, which is equal to 1, then x is equal to negative 1. Then the focus is located at the coordinate 1 and 0. And then for the axis of symmetry is y is equal to 0. And then what is the length of the latus rectum? Substituting the value of the p, which is equal to 1. So 4 times 1 is equal to 4. Then we can say the length of the latus rectum is 4 units. And then what is now the coordinate of the endpoints of latus rectum? Substituting the value of the p now, coordinate 1 and positive negative 2. So, to simplify further the endpoints of the latus rectum, so we have now coordinate 1 and 2 and coordinate 1 and negative 2. So if we are going to sketch now the the graph of the given equation, y squared is equal to 4x. So first is we're going to locate the vertex, then the directrix. Since the directrix is x is equal to -1, that is now a vertical line that passes through -1 in the x-axis, and the focus is located at coordinate 1 and 0. So as we're going to plot now the focus, this is our focus, coordinate 1 and 0, and then the endpoints of the latus rectum. So remember that the latus rectum will pass through the focus and perpendicular to the axis of symmetry. Then as we are going to plot now the coordinates of the endpoints of the latus rectum, coordinate 1 and 2 and coordinate 1 and -2. This is now the location of the endpoints of the latus rectum. As we are going to look at the length of the latus rectum, that is 4 units, then we can now graph the equation y squared is equal to 4x. Example number 2. Sketch and discuss the equation y squared is equal to -8x is a parabola with vertex at the origin. Our 4p is equal to 8. If we have now -8 as coefficient of x, we are going to get now the absolute value of -8, that is +8. So we are going to divide both sides by 4 in order for us to find the value of the p. Then we can say p is equal to 2. So as what you can see, y squared is equal to -8x is in the form of y squared is equal to -4px in standard form. So if we're going to look at now the coordinates and the equations of the parts of the parabola, having the equation of y squared is equal to -4px are now the coordinates and the equations of the parts of the parabola. So let us now identify what are the equations and coordinates of parts of the parabola. X is located at the point of origin. Then the equation for the directrix, since the value of p is 2, then we can say the equation of the directrix is equal to x is equal to 2. For the focus, is located at the coordinate -2 and 0. Then our axis of symmetry is y is equal to 0. Then the length of the latus rectum is 8. It is because 4 times 2, the value of the p, that is equal to 8. Then what is now the coordinate of the endpoints of the latus rectum? Substituting now the value of the p, which is 2, in this coordinates, then we can say coordinate -2 and +2 times 2. We can say that the coordinates of the endpoints of the latus rectum is -2 and +4. So if we're going to split this one into 2 coordinates, the coordinates are coordinate -2 and 4 and coordinate -2 and -4. So let us now graph. So first thing that we need to do is plot the vertex, then locate the focus. The focus is located at the coordinate -2 and 0. So as what you can see, since now the focus is at the left side of the vertex, then we can conclude that the directrix is at the right of the vertex. And the equation of the directrix is x is equal to 2. When you say x is equal to 2, straight, it is a vertical line that passes through the x-axis at 2. Then we are going to sketch the latus rectum. So since the directrix is vertical, then we can say that the latus rectum is vertical also. From the focus, we're going to count 4 units upward and then 4 units downward. So as what you can see, the endpoints of the latus rectum are coordinate -2 and 4 and coordinate -2 and -4. And take note that the axis of symmetry is the x-axis. So the equation of the x-axis is y is equal to 0. And this graph describes the equation y squared is equal to -8x. Example number 3. Find the equation and the length of the latus rectum of the parabola with the directrix y is equal to -4 and focus is located at coordinate 0 and 4. sketch the graph. First thing that we need to do is we are going to graph the directrix. Since now the directrix is y is equal to -4, it means this is a horizontal line that passes through -4 at y-axis. And we're going to locate now the focus. The focus is located at the coordinates 0 and 4. The opening of the parabola opens upward since the focus is above the directrix and whose vertex is at the point of origin. The distance of the focus perpendicularly to the directrix is 8 units. Remember that the distance from the focus to vertex is p units, and the distance from the vertex going to the directrix is p units. So if you're going to sum up all the distances from the focus going to the directrix, that is equal to 2p. So in the given problem, distance from the focus going to the directrix is 8 units. So we are going to equate now 2p is equal to 8. In order for us to find the value of the p, divide both sides by 2, then we can say the value of our p is 4 units. It means that from the vertex going to the focus is 4 units. From the vertex going to directrix, that is 4 units also. And take note that the equation of the parabola whose vertex at the origin and opens upward is x squared is equal to 4py. If we are going to substitute the value of p, which is 4, in our equation, x squared is equal to 4py, that is x squared is equal to 4 times 4y. Then simplifying further, 4 times 4 is equal to 16. Then we can say that the equation of the parabola is x squared is equal to 16y. What is the length of the latus rectum? Since now the length of the latus rectum is 4 times the value of the p, then our latus rectum is 16 units. The endpoints of latus rectum of the parabola whose vertex is at the origin and opens upward is coordinate positive, negative 2p and p. Substituting the value of the p, which is equal to 4, then we have positive, negative 2 times 4 and 4. Simplifying further, we have now coordinate positive, negative 8 and 4. So if we're going to split this into two coordinates, the coordinates are coordinate 8 and 4 and coordinate negative 8 and 4. So we can now graph x squared is equal to 16y. So this is now our latus rectum. So from the focus, we are going to count 8 units going to the right. And from the focus, we are going to count 8 units going to the left. So as what you can see, the endpoints of the latus rectum are coordinate 8 and 4 and coordinate negative 8 and 4. So this is now our graph for the equation x squared is equal to 16y. Example number 4. Find the focus, directrix, length of the latus rectum, endpoints of the latus rectum, and the equation of the parabola whose axis of symmetry is vertical. Vertex at the origin and passing through the coordinate 4 and negative 2. Sketch the graph. So as we are going to plot now the given information, vertex is located at the point of origin, and we all know that the axis of symmetry is vertical, then it will pass through the vertex. P, we're going to set the given as point P having a coordinate of 4 and negative 2. By the given information itself, then we can say that the axis of the parabola is the y-axis with the vertex at the point of origin. The parabola opens downward and passing to the point P, x, and y. And we let now be point x and y be coordinate 4 and negative 2. Then we have now an idea that the parabola opens downward. As we are going to recall back now the standard equation of the parabola whose vertex at the origin and opens downward, the equation is x squared is equal to negative 4py. So let us now identify the value of the p so that we can easily now graph the parabola. As described in the problem, substituting the value of the x, which is equal to 4, and y is equal to negative 2 into the equation of the parabola x squared is equal to negative 4py to find the value of the p. So we have now 4 squared is equal to negative 4p times negative 2. As we are going to simplify further, 4 squared is equal to 16, and negative 4 times negative 2, that is equal to positive 8. So in order for us to find the value of the p, let us now divide both sides by 8. Then we can say that the value of p is equal to 2. Since we already find the value of the p, which is equal to 2, we can now identify the focus. The focus is coordinate 0 and negative p. Substituting the value of the p, then the focus is located at the coordinate 0 and negative 2. So if we're going to plot now, this is the location of the focus, coordinate 0 and negative 2. How about for the directrix? The directrix is y is equal to p. We can say that the directrix is y is equal to 2. It means that this is now a horizontal line that passes through the y-axis at 2. And for the length of the latus rectum, that is 4 times 2, that is equal to 8. And let us now identify the endpoints of the latus rectum, having now the coordinate positive negative 2p and negative p. Then substituting the value of the p, then we have positive negative 2 times 2 and negative 2. Simplifying further, we have now coordinate positive negative 4 and negative 2. If we're going to split this one into two coordinates, then the coordinates are coordinate 4 and negative 2 and coordinate negative 4 and negative 2. As we are going to plot now the endpoints of the latus rectum, so the first coordinate is negative 4 and negative 2, and the other coordinate, the point P, 4 and negative 2. And take note that the equation of the parabola whose vertex is at the origin and opens downward is x squared is equal to negative 4py. Then substituting the value of the p, our p is 2. Then we have now x squared is equal to negative 4 times 2y. Simplifying further, we have now x squared is equal to negative 8y. Then this is now the sketch of the parabola whose equation is x squared is equal to negative 8y.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.